Hi, my name is Jared Matisoff, and this is my Lab 1 video report. In this lab, we studied constant velocity motion. In this lab, I recorded the motion of a rolling marker as it moved across the table. We placed a meter stick next to the marker in order to gauge distance traveled. So here you can see it. Play it one more time for you just to get a better understanding. So, for the purpose of this lab, the purpose of this experiment is to test constant velocity motion. In physics, constant velocity means that an object moves equal distance in equal time intervals without changing any speed or without changing any direction. So this lab was a pretty simple lab to set up, as being able to tell from the video. You need a marker, flat surface like a table, a calibration stick to be able to tell the motion. So in this, we use a meter stick. You're going to need a camera to record the video, and then you're going to need a computer for the tracker app and GlowScript. Now, the marker is pretty optional. There's other objects you can use. It just needs to be something that's going to roll in a straight line. That way that the constant velocity is going to be able to be sought out. So going on to the data collection, as you can tell, there's 20 data points on the tracker and 20 data points from GlowScript. So using the tracker, I tracked 20 points, and then we use the computational model in GlowScript to get those 20 points. And then what we're going to do is we're going to compare them to see the difference, to see if in the lab experiment, if anything went wrong. So here's our results. As you can see, pretty similar. The blue is the tracker and the red is the GlowScript. So when I graphed the position versus time, it's nearly a straight line, which means that the marker's velocity was pretty constant. The GlowScript model also produced a straight line motion, which matched the experimental data closely. And now there can be small differences that caused the line not to be straight, like any outside forces such as friction or air resistance, or even just a measurement error. So my hypothesis is that in this study, air resistance and friction were pretty negligible. This is due to the nearly straight line slope. So although there might have been friction, because there's a table and maybe there's a little wind in the room, who knows, that it might be there, but it's negligible. If it was not negligible, then it wouldn't be so linear like it is. So now we are going to go on to the what ifs. So the what ifs, there's two questions we were asked. The first one is what would happen if you switch the axis orientation tracker. So in this case, the slope of the graph would flip change. It would be a negative slope, but the magnitude of the velocity would be the exact same. So it wouldn't really affect the data at all. Secondly, a question was asked, what does it mean by setting net force equal to 0? This just means that that the net force equals 0. So no forces exist that would act on the motion. So although there's obviously gravity and there might be a little friction and normal force, these all balance out to equal 0, which would not affect the motion of the marker. So with no net force, this means the marker has a constant velocity because there's no acceleration which would speed up or slow down or change the direction of the marker. Since F equals ma, if acceleration is 0, then net force equals 0. So in conclusion, this lab demonstrates the idea of constant velocity. By using the marker, a simple object, it represents how physics exists within everything around us and everything we witness in the world. So it also confirms that when net force is 0, motion continues at constant velocity, which is what we could predict from Newton's laws.